Oops, that's not what I want to show. And we've got, oops. Okay, everybody, let's see. Make sure this is probably, oh, no, that is set, right? Okay, great. Okay, I think we are set and ready to go. So welcome on in. Time to start talking about factoring a little bit. So we kind of talked about polynomials before. We're going to be getting into factoring now. Let's see, what do we got? 11 days. Yeah, that's about right. We'll see how it goes. I think that's about right as far as timing of things. So we are getting into factoring today. This is one of the most important topics in this course, right? Sort of, if I had to pick 3 things that you need to know going forward: systems of equations, dealing with lines, that is graphing and finding equations of lines, and factoring. And honestly, as far as like your future classes, maybe even just factoring and lines are like the 2 most important things that you need when you leave this class. If you can't do equations of lines, you're not even going to have the math you need for statistics, which doesn't have a ton of algebra in it. A lot of the stuff, if you're going, say, college algebra or pre-calc or trig or something like that, you absolutely are going to be factoring all the time. And you don't have the time in those classes to learn factoring because factoring is like the first step of like 10 steps. And if you can't do step 1, then how are you possibly going to do the other 9, right? It's too much. So factoring is very, very important. It comes up a lot. It seems silly, right? When you talk about, like I kind of explained it yesterday. So if we look at this, let me kind of remind you what I was talking about. What? How did that happen? That's weird. Take, for example, we have, here's what we did last time. We talked about factoring, or we talked about multiplication last time, right? So if we have something like 2x plus 1 times 3x minus 5, let's see where it's going to show up here. There we go. There it is. Okay, so last time we talked about polynomial multiplication, right? So if we take this and multiply this out, remember FOIL? We talked about FOIL, which is just, again, polynomial multiplication is just take every term in one polynomial, multiply it by every term in the other polynomial, combine like terms. That's all it really comes down to. Lots of different organizational methods of setting that up. That's great. It doesn't matter because they all come down to what I just said a second ago. FOIL does that. It takes every term over here and multiplies it by every term over here. It's just a way to remember the steps a certain way. So if we do that, we're going to get what? I'm going to get, what do we get? 6x squared minus 10x plus 3x minus 5. Which, I did what I said. I took every term in the first polynomial, multiplied it by every term in the second one, right? You can go through. That's 4 multiplications. We've got our 4 multiplications there. Oh, except we need to simplify. We always want to combine those like terms when we can, right? So that's going to give us 6x squared minus 7x minus 5. So right there we see, and it'll show up. There we go. We see our simplified version of this multiplication. Let me make sure I got that right. Yeah. Okay, so there we've done the multiplication, right? We started with something that was written as a product, and we multiplied it out, and now it's written as a sum or difference. That's multiplication. That's what we did last time. The rest of this chapter, the rest of this unit we're looking at, and remember, at the end of factoring, we have the exam. So that's, roughly 2 weeks away, something like that, in the neighborhood of 2 weeks. Next week, we can probably pick an exact. I can give some details about exactly when the test will be. But so this process for going where we have something written as a product to where it's written as sums and differences, that's called multiplication, right? Going the opposite direction where we have something written in this form, which remember that's our standard form for a polynomial, To work backwards and write it as a product, that is called factoring. Okay, now you've kind of already done this in non-polynomial settings. Remember in your pre-algebra when you broke things down as a product of prime numbers, right? That's really what we're doing here. We're breaking these down as a product, right? So when you took, remember when you would do this, this was a pre-algebra exercise, you'd have, say, the number, let's say the number, 22, right? You want to break this down into its prime factorization. Then what would you do? You would say, okay, well, 22 equals 11 times 2, right? So you're taking one thing and you're breaking it down as a product. So we did this with numbers, and we can see that, yeah, there's definitely times where it's useful to know how to break a number down. You do this when you simplify fractions, and we use it all over the place. Well, it's used a lot as well when we have polynomials. You'll be doing this a lot in your, depending on what math class you take. It doesn't come up in statistics, but it comes up in the other algebra classes where we want to write things as a product. For instance, the first thing we're going to do, I think sometimes one reason people don't love factoring is because they're like, who cares? When am I ever going to use factoring? Why do I need to learn this? Well, at the end of the chapter, we will use factoring to solve equations that as of yet you have no other way to solve. So we will use factoring to solve those equations. If you don't know how to solve them with factoring, you're out of luck, right? There are other ways to do it, but you haven't learned them yet, okay? And those other ways are a ton more work. So when you can solve an equation using factoring, you're better. Now notice I don't have an equation written here. That's another thing that's really important in this chapter because you're going to be factoring a lot of problems that say factor, and then you're going to be solving equations that say solve. And I see students sometimes, they get the right thing to do, but they do it at the wrong time. In other words, a student will be given an expression and told to factor it, and they'll do some weird stuff and then try to solve it. And you can see they're doing they're factoring and they're doing the right thing, but then they go sort of sideways and they complete the problem incorrectly. Or the other thing that happens is someone's given an equation and told to solve it, and they factor it correctly, but then they stop, right? So it's really important that you pay close attention, especially on the test, right? It's always a bummer when I have to give out a low score on a problem because I'm looking at it and I go, this student kind of knows what they're doing. They just didn't read the directions, right? So make sure that you pay attention. We talked about this at the beginning of the semester, the difference between an expression and an equation. How do you know when something's an equation? It has an equal sign in it. How do you know when something's an expression? It does not have an equal sign in it. So generally when you're being given an expression, you're going to factor it. When you're going to be given an equation, you're going to solve it. Now you won't really see equations until later in the chapter, but just sort of, there's sort of two clues when you're doing a problem, right? One is if it's an expression, I can't solve it, so I must be factoring it probably. And if I'm given an equation, well, why would I just factor an equation and not solve it, right? So there's just kind of looking at the object that you were given and identifying whether it is an expression or an equation should largely clue you in to what it is you're supposed to do. But there's a second big clue, which is read the directions, right? And I'm not trying to say that in a snarky way. I mean, literally, that's becoming more and more a thing that happens where students don't read the directions and they just jump right into the problem and try to get an answer. If you haven't read the directions, you don't even know what you're supposed to do, right? So there's two clues when you're looking at these problems about whether you're going to factor or whether you're going to solve. So just sort of get used to be observant, right? Observe what the questions look like now so that later when we start throwing in the equations to be solved, you recognize the difference and you go, oh, I see. This one has an equation and the direction says solve. So then I'm supposed to solve. Okay, so just kind of try to be aware of that so you can recognize those differences. Okay. Now, the multiplication I know took a little bit of practice, right? It takes a little while to sit down. You're doing some homework. You're working on it. But generally, what I find is people figure out the multiplication at some point, right? Whether you use box method or distributive property, whatever it is you like to call it, students figure out their own way, the way that they like of organizing the multiplications to make them work. Students don't usually miss problems on the multiplication problem on the test. They usually get it right. Factoring is more challenging, right? And I think I talked about it last time. It's not just like my opinion that it's more challenging. Just from a scientific standpoint, it is mathematically more complicated to factor something than to multiply it out, right? You can easily program a computer to multiply things together. It's a lot harder to find an efficient way to factor those numbers, right? So for instance, we could write a program here that would multiply really, really big numbers together. Like say we take two 100-digit numbers and multiply them together, and we might have to wait, I don't know, a minute or something for the computer to go through, because that's a lot of calculations. Might have to wait a minute for it to get that answer. If we took those same three numbers, the two numbers being multiplied and the result, and we turned it around and said, okay, computer, now try to figure out how to break this multiplication down into smaller products, it could take years, right? So it's just a more complicated process. And I think I'd mentioned last time that idea is actually a lot of what keeps your things encrypted online and safety and stuff like that. So just know it's more complicated to work backwards, because look at this. If you're multiplying, you have all the information you need. Well, I've got 4 terms, and I'm going to go through and do different combinations of multiplying these together, but all the information you need is right in front of you. That's why it's really easy to program. You just say, okay, multiply this by this, and then this by this, and this by this, and this by this, and then add together like terms, and then you're done. But notice if you just start with this trinomial down here, and you try to work backwards to the product, well, there's stuff you don't know. Like, well, where did this 3x come from? And where did this 1 come from? And here's a 2. The only number that really shows up here and here is the 5. So it's harder to work backwards through factoring than it is to work forwards through multiplication. So just sort of know that. Now, that's not to say it's hard. Most students, if they go through and do the homeworks, they pick it up and go, okay, after you do 5 or 10 of these, it just kind of becomes a thing that you're like, okay, I have this process memorized. I can go through and do this. And students are fine with it. But it does take a little bit more work to get comfortable with the factoring. Part of it is, too, when you're multiplying polynomials, whether it's a binomial or a trinomial or, whatever method it is, the way you have your work organized probably doesn't change much from problem to problem. But with the factoring, there's like, I'm trying to count, I don't know, six or seven like very different ways that we factor. So one of the things you're going to have to do is recognize which factoring technique am I supposed to use for this particular problem. So that's another bit of observation that you want to work on. You want to get to the point where you look at a problem and you go, that's going to be factored by grouping. And you look at a problem and you go, that's difference of squares. And you look at a problem and go, oh, that's trinomial with lead coefficient 1. That's trinomial with lead coefficient not 1, right? Because if you can look at the polynomial and identify which method you're supposed to use to factor that, that's like half the battle right there. Okay? So don't just sort of like... It's easy for students to be kind of overconfident in this area because they go, yeah, well, when I was doing the homework, I was able to do them all. And then they have a lot more trouble later in the chapter. Here's why. When you're doing the homework, it keeps feeding you very similar problems. So when you're doing difference of squares and difference of cubes, every problem is a difference of squares or difference of cubes. You don't really have to think about much, right? When you're doing trinomials, every problem's a trinomial. So you don't have to really think about it. When you're doing factor by grouping, every problem is factor by grouping. But at the end of the chapter, they stop doing that, and all the problems come together, and you're just given a polynomial and told, okay, go factor this. And you have to go, well, wait a minute. Am I supposed to use difference of squares, or am I supposed to use trinomial, or like what is it I use? You have to have that that tool developed to recognize which to use. So start looking now. Start be a little detective when you do a problem. Look at it and go, and I'll mention some things to look for, but people miss that. Look at it and go, oh, I see. This is what the factor by grouping problems all look like. So when I see that, I can recognize to use factor by grouping. That's like half the issue that I see, right? I get that question too in class. Students come up and go, which method am I supposed to use to factoring? And then you explain to them and they go, oh, and then they can do it. They're like, okay, I know how to do it. I just couldn't figure out which one it was. How did this? Oh, sorry. I do have a mistake here. Yep, this should be a 6. Looks like I have a typo. Thanks. I probably said 1 and then hit the wrong button there. So there we go. 6x squared. Thanks, Chase, for pointing that out. Yeah, that should be a 6x squared. But we still see the same issue, right? Is these numbers up here, it's like, well, where did you get those from here, right? We're breaking these down, like the 7. There's no 7 and no 6. So so it's a little trickier. Okay, so that's what we're going to look at is how to do that. Oops. I didn't get my book out just so I can grab some examples. If I need some. Okay. The first method we look at is kind of the easiest. And the good news is it's always what you should do first. This should always be the first thing you look for is what's called the greatest common factor. Should always be step number 1. Now, a lot of the problems we do in this chapter, there will be no greatest common factor. So then you skip over that step. But when that step is possible, you should always do it first. There's 2 reasons why you do it first. One is that some problems are impossible until you factor out the greatest common factor, and then there'll be like other steps of factoring after that. So basically, you just can't continue until you do the factor by greatest common factor piece. The other reason that we do it first is because sometimes you can do greatest common factor as your second step if you want to, but that's always going to be the harder way to do it. So if you can choose between there's going to be problems where you can do greatest common factor first, trinomial factoring second, or you can do, if you really wanted to fight it, you could do the trinomial factoring first and then greatest common factor, but it's always going to be harder to do it that way. So if you just always look at a problem and go, is there a greatest common factor? And if the answer is yes, then factor it out. If the answer is no, then move ahead. It'll be a lot simpler for you. Okay. This will become more relevant again at the end of the chapter, because in the middle of the chapter, most of your problems aren't going to have a greatest common factor. And then at the end of the chapter, they start giving you a bunch of those again. So just sort of be aware of that. Okay, so let's look at what I'm talking about. So let's say we want to factor. So see how those directions are there? It's telling you factor. And then also what we have is not an equation. So both of those pieces are clues telling us we should be factoring, not trying to do some solving or something. So let's see, 12x to the 5 9x cubed plus 6x squared. Okay, so here we have a trinomial. Let me see. Maybe this would be good if I made it larger. This might be too large. Let's see. Oh yeah, that's too big. Let's make this a little smaller. Still pretty big. I may have to shrink it down here in a little bit, but we'll see what that looks like. Okay, so here we have a trinomial, and we want to factor this using the greatest common factor. So what does that mean? Well, remember common factors, you did this in simplifying fractions. You'd look at the numerator of the fraction, and you'd look at the denominator of the fraction, and you'd say, what can I divide out from the top and bottom of this fraction, and then cancel those, right? Well, you're looking at what they have in common. Well, what does this have in common? Well, these polynomials have two parts, essentially. You've got your coefficient part, and you've got your variable to a power part, right? Each of these is that. We have a coefficient, variable to a power. Coefficient, variable to a power. Coefficient, variable to a power. So then you just break it up into those two pieces. What's the biggest thing that I can factor out from the coefficient? Well, let's see. I've got 12, -9, and 6. What should I try to factor out from a 12, a -9, and a 6? And the answer is the biggest thing that all three of those numbers have in common is 3, right? They're all divisible by 3. So I'm going to take out a 3. Okay. Now I look at the variable, and I ask myself, what's the largest power of the variable that I can pull out from all three of these terms? Well, from this first one, I could pull out 5x's. From here, I can pull out 3x's. From here, I can pull out 2x's because it's an x squared. So that means the biggest thing I can pull out from all of them is 3x squared. Okay. So one way the books describe it, which I'll go over it, but I actually think confuses at least a certain number of students. It's basically the smallest power that occurs on any of that variable. So see how this variable has a 5, a 3, and a 2? So the biggest one you can pull out from all the terms is the smallest one, 2. But it's kind of weird because we're talking about biggest, smallest, and students start getting confused. Like, wait, which part's the biggest? Which part's the smallest? It's the smallest exponent that occurs on all of the terms. Okay, that's the biggest thing we can pull out. All right, so it's kind of like reverse distributive property here, right? We're dividing a 3x squared out from each of these. So what's left once I divide out the 3x squared? Well, from the first term, I'm left with 4x cubed, right? Because that's what's left once I take out the 3x squared. Minus 3x. Watch those signs. And then let's see, what, plus 2? Okay, we just factored this problem using the greatest common factor. Notice how it started off being written as a plus or minus. It's now being written as a product. We have a 3x squared times whatever's in the parentheses. It's a product now, right? And you could argue, yeah, but we still have plus or minuses in here. That's okay. We now have a product in here. So I told you at the end of this chapter, we'll be solving equations. The next chapter that we do, I think it's the next one, when we do rational expressions, you'll use this factoring to simplify really complicated fractions. It gets used for all sorts of stuff. Factoring gets used all over. So we've now written as a product. There's nothing more that we can pull out from these, so we're good. We're done. Okay, we just did that. So let's take a look at what these look like in here. So let's look at a couple homework problems. So factor the expression completely. Okay, what can I take out from both of these? And this is a good one because students mess this one up a lot. They take out a 4, which is the right thing to do. And they go, okay, well, when I divide in fact, they say take out, but you should be thinking division. When I divide a 4x out of the, 4 out of the 4x, I'm left with an x. And then they go, well, once I take the 4 out, there's nothing left, right? So that, like, this is what I'll see a lot is students will write this 4, and when I take the 4 out of here, or they'll write it, I see lots of strange ways, but maybe like that. And then they go, yeah, because the 4 is gone, there's nothing left there. And then look, it's going to tell me I'm wrong. Nope, you're wrong. So what did I do wrong? When we divided the 4 out, remember we're dividing. What is 4 divided by 4? It's not 0. Right? You always want to do problems thinking mathematical operations. This is part of the problem is people try to memorize like moving things and things disappear and stuff like that. Don't do that because those aren't like disappearing and moving. Those aren't mathematical operations. If you use the right vocabulary, and this is why a lot of us teachers, a lot of times students are like, well, why are you making me say it the right way? It's because if you use the right terms, you'll do the right operations. This is a division. 4 divided by 4 is 1. Okay, so 4 times x plus 1. And here's something that's really great about factoring is it's kind of like systems of equations where it takes a lot of work to do the factoring, but checking your work, really easy. All you have to ever do, right? Remember, multiplication is the opposite direction of factoring. So guess what you do to check your factoring? You multiply everything out again. If you factored something and you multiply it out and you get what you started with, you know you did it right, right? It's basically, you know, has to work. So, if I multiply this in again, 4 times x is 4x. 4 times 1 is plus 4. That should be correct. And there we go. Okay, so see how that works? Let's do a trickier one here. Not tricky, but like little more work in there. That one's still kind of the same thing. Okay, so I look at this and I have to ask myself, what is the greatest common factor of these terms? Well, let's see. Only one of the terms has an x in it, so they don't have an x in common. But one has a y squared and the other one has a y to the 5th. So what's the highest power of y that I can take out from both terms? It would be y squared, right? Remember, it's the smallest of the variables that occurs in both terms. Like, it gets confusing, but just think, what's the biggest thing I can take out from both of these? Oh, a y squared. So I'm going to go y squared. And remember the caret, the button that's on the 6, if you go, so I do y, you can do it this way by opening this up and hitting the, if you hit the calculator, it gives you a little exponent button. But also if you don't want to have to keep reaching for your mouse all the time, you just go y, use the caret, which is shift 6, and it puts you right up in the exponent, squared. Oops. And then to get out of it, you can just use the arrow button to get back down. And then, so what's left when we divide y squared out? Well, in the first term, we're left with an x to the 5th. And then I'm left with a y cubed on the other piece, right? And notice if I multiply my y squared back in, I get what I started with. So I know that's right. Okay. And it's factored. Notice how we went. It wasn't written as a product up here. It is written as a product down here. It's y squared times what's in the parentheses. Okay, so you have a product. Okay, let's go back and look at, let's see, multivariable. Wait, but that last one was multivariable. I guess this one's really multivariable, I guess. That's kind of a weird way they have it labeled. So I look at this and I go, let's actually, I'm going to get this one wrong. Oops, that's not what I want to do. Because I'm hoping we'll get another one. Yeah, okay, here's what I was hoping for. Okay, so notice how here we have both these have coefficients, both these have a set of variables. So I just look and I go, okay, 15 and 9. What's the biggest number that divides 15 and 9? It's a 3. Okay, so I'm going to factor out a 3. And then I look at my x's. Do x's occur in both terms? No, so they're not in common. Right? Remember what the term for common means in mathematics. Like when we use the word common, a lot of times that means like you see it a lot, right? Those of you who are gamers, a lot of times like items in games are rated as common, like you find them a lot. In mathematics, when we talk about common, that means shared. That means that like it occurs in both of those things, right? So if we have something in common, that means that we both have that attribute, right? If we both like writing, we have that in common. That's what we mean in mathematics when we say something is in common. We mean we both have it. Okay. So do both of these have x's? No. Do both of these have y's? No. Do both of these have z's? Yes. Okay. How many z's do they have in common? 2. Because this has a z squared, but then it also has 3 more z's on top of that. But this term only has a z squared. So 3z squared is the biggest thing that we can factor out. And then what's left when we take 3z out? Well, let's see. And here we're left with a 5x squared y to the 4th y squared, no, y to the 4th, and then z cubed. Let me see if I got that. Yeah, okay. All right, so that's what's left of the first term. Now when I take 3z squared, when I divide that out of the second term, what am I left with? Negative just 3, right? Okay, so they go through and kind of walk you through it a little bit, but that was the idea. Let's see what's the next one look like. Here we go. Here's one that's a little more going on. And these can look intimidating at first. You're like, man, there's so many variables and there's like these big numbers. Like, don't sweat it. Just break it down into the individual pieces. Look at the coefficients first. Then look at the x's. Then look at the y's. Then look at the z's. So break it up into 4 steps rather than getting overwhelmed with the whole thing at once. I definitely see students who look at a problem like this and it just scares them and then they can't do anything. So break it down into little pieces. What's the biggest number that goes into 18 and 27? Looks like, again, 9 goes in there. Okay, so 9 goes into 18 and 27. So we're going to take out a 9. All right, how many x's are there in both of them? So they have 4 x's in common, x to the 4th. Looks like 4 y's in common, y to the 4th. And then 3 z's in common. Now we just have to figure out what is left. Okay, so let's see. What's left in the first term? Well, we took a 9 out. We divided a 9 out, so that's leaving us with a 2. We have 2 more x's. We have 4 more y's. Keep doing that. I'm used to another piece of software where you don't have, I think it's Desmos, where you don't have to keep doing that. Y to the 4th. And then nope, z's, we took out all the z's. So, all right, if I go 18, x to the 6th, y to the 8th, and then z. Okay. And then minus, so 27 divided by 9 would be 3. Let's see, we took out all the x's, we took out all the y's, and we took out, hold on one second. Hello? Sorry about that. It ended up being nothing, but my son is doing some stuff today, and I had to double check that wasn't him trying to get a hold of me with someone else's phone or something. So sorry about that interruption. So where were we? 27 divided by 9 is 3. Watch those signs, right? Because negative 27 divided by 9 should be negative 3. All right, the x's were all divided out. The y's were all divided out. It looks like we're left with 3 z's still. And there we go. We got it. So again, don't try to do the whole problem in your head at once. That's pretty much true for most things from here on out. Don't get overwhelmed by big problems. Break them down into smaller pieces and just see, what can I do on this individual piece? That's what people do who are good at math. You don't look at an entire problem at once and get overwhelmed. You go, okay, is there one step I can take here? Yes, I'm going to look at the coefficients. Okay, now that I've done that, is there another step? Yeah, I'll just do the x's. Is there another step? I'll just do the y's. And you just keep doing that, and then all of a sudden the problem's done. Okay? Let's see. We don't need to do any more of those, I don't think. And then I think we've got, yeah, and then we've got our factor by grouping. So factor by grouping, I'll show you in a second how to do it, but this is what your problems look like. So again, what do you notice? The directions say to factor, and we don't have an equation. We have an expression. So that's 2 clues telling me I should factor this thing. Okay, so see how this problem cannot be simplified? There's no like terms, right? So that's as simplified as it can get, and there's 4 terms. Like 99% of the time, if you have 4 terms that can't be simplified, the way you're going to factor it is with this technique called factor by grouping. So just notice that when you're doing the homework and get comfortable with it and realize, oh, if there's 4 terms, I'm probably going to use factor by grouping, because even though it says it up here, factor by grouping, later on in the chapter, you're not going to have that clue. So you're going to want to recognize, oh yeah, when there's 4 terms, I should use factor by grouping, and then you're going to know which one to use. So just kind of put that in your head now. 4 terms, factor by grouping. Okay, if you can remember that, you'll be done with these problems before other people even get started, right? Okay, so how does factor by grouping work? Let's take this problem and talk. I'll actually do this one, but we'll do it over here. So let's go. So what was it? 2x cubed minus 3. Nope, minus 7x squared plus 50x minus 7x squared plus 50x minus 175. All right, so 2x squared minus, 2x cubed minus 7x squared, 2x cubed minus 7x squared plus 50x minus 175. Okay, so we are going to factor this using factor by grouping. Now, what are we supposed to do? Well, it's called grouping because we're going to create 2 groups. We're going to create this front group with the first 2 terms, and we're going to create a second group with the back 2 terms. And what we do here is we take out the greatest common factor from each group. Notice there's no greatest common factor for the entire expression. Sometimes students get confused and they go, but there is no greatest common factor because look, this has a 2x squared or 2x cubed. This doesn't have any x's and it's not even, so there's nothing in common. Right. So this special technique is we think about the first term as a group and the second term as a group, and from the group you factor out the greatest common factor. So the next line, okay, what can I take out from these? Well, a 2 and a 7 don't have anything in common, so we're stuck there. What about x cubed and x squared? I can take out an x squared. So x squared, that's going to leave me with 2x minus 7. Okay, do you see how I did that? So I just factored an x squared out just from the first group. Okay. Now I'm going to figure out what I can factor out from here. Well, 50 and 175, what do those have in common? Like 25? Okay. So let's factor out a 25. So I'm going to factor out 25. There's a bad habit that some students form right here where they don't write this plus. But if you don't write the plus, that implies a multiplication, and then students start doing weird things like multiplying things they're not supposed to. So make sure this plus remains in the problem. If it goes away, you're likely to go off the tracks. Okay, so that plus remains. When I factor out 25 out of this, what do I get? Oh, well, 50 divided by 25 is 2, and then I'm left with an x. So it looks like I have a 2x there. And what is 175 divided by 25? Well, in 100, there's 4 25s. And then with the 75 left, that would be another 3. So it looks like it's 7. So a negative 175 divided by 25 is minus 7. Okay. Notice if we just redo the multiplications that we have here, we just get the top line again. Right? If I multiply this x squared back in, I get these 2 terms. If I multiply the 25 back in, I get these 2 terms. But now notice what do we have? We have 2 terms here, really. We have this first one, and then we have this second one. But do they have something in common? They do, right? They have a shared factor of 2x minus 7. Now, this is the point where some people panic and go, what? It's a binomial? It doesn't make any difference if the thing in common is a monomial or a binomial or whatever. It makes no difference. They have it in common, so it is a common factor. Okay, you're going to do this a lot. So you just recognize, okay, they each have a 2x minus 7 in them. So just like you did up here where you factor out an x squared, Here we're going to factor out a 2x minus 7, right? And it's okay if this is worrying you, but what I'm just trying to say is don't overthink this step, right? You're doing the same exact thing we did at the beginning. Here, I took out an x squared, I brought it to the front, and I divided it out. That's what we're going to do here. We have a common factor of 2x minus 7. So we bring that factor to the front, and then we write what's left when I divide it out. Well, when we divide 2x minus 7 out of here, we're left with what? An x squared. And when I divide the 2x minus 7 out of this piece, I'm left with what? A plus 25. And what we have just done is factor this equation. Notice how it's now written as a product? We have that multiplication going on here. That was our goal. That is factor by grouping. And it's kind of nice because it's just 3 lines. And the original line is just the original problem, right? So it's really only 2 steps and you're done. Now, do they get more complicated than this? They can. But even the complicated ones only take like 3 lines. It doesn't get any longer. Whereas the trinomial problems that we'll talk about probably next time, they can get really complicated. In fact, a lot of times what people do is they convert their trinomial problems into factor by grouping problems. I do that when I have to do a really complicated one. I'll convert it to this. I'll show you how to do that next time. But this is a good way of doing these problems. In fact, that method that I just talked about of converting other problems to match the factor by grouping, some students do that because almost every single problem, not quite every single problem, but most of them in this chapter, if you learn how to convert them to a factor by grouping problem, then these students just get really good at factor by grouping, and anything you give them, they convert it and then factor by grouping. So if you're just doing factor by grouping every single time, you're going to get good at it, right? But and that's okay if you don't want to do it that way. If you want to do it by all the different like 6 techniques, it's a good thing to know how to do those as well. So either way. Okay, so let's put that in and double check that I'm right. So we had what? 2x minus 7. And x squared plus 25. There we go. Got it correct. Now, a question that I often get right now, and it's actually a very reasonable question to ask, right? It shows that people are paying attention and trying to think through problems. So it's a good question. I like when students ask it. But the question is, you know, I just did the same problem you did, but I got a different answer. I got the following. I got x squared plus 25 times 2x minus 7. Right? I'll have a student come up and say, but I got this as my answer. They're both right. And Delta Math will take both of them as the answer, right? So if you look at it, what was done? The factors were just written in a different order. The exact same factors, but written in a different order. So think about it this way. 5 times 4 is 20, but 4 times 5 is 20. It doesn't matter if the 5 is first and the 4 is second or the other way around. You get 20 either way, right? It's the same way here. If I multiply this out, I'm going to get the top row. If I multiply this out, I get the top row. They are both correct. Okay, so, and I'm kind of skipping the step because we're getting low on time here, but remember what we should do, double check it by multiplying this out. So I would just FOIL this, and if I got the thing at the top, I'd know I did it correct. Okay. Now, here's what I'll say. Be careful because sometimes when I say, just so you know, these are the same, then someone will come back and say, well, you told me they're the same, but it keeps marking me wrong, and they have something like the following. Right? A student will come up and show me this and say, well, you said it didn't matter what order I write it in, but it's giving me the wrong thing. Well, look closely. These are not the right factors. Sure, you have a 2x and a 7 and an x squared and a 25, but your signs are wrong. The correct one is 2x minus 7. You have a 2x plus 7. and this is supposed to be x squared plus 25, you have x squared minus 25. So a lot of students will get really close, but their signs keep messing up their signs. If the signs get messed up, it's wrong. For instance, let's do it. We have enough time. Watch if I multiply this out. The only thing wrong here is my signs, right? The numbers are still the same, 2x, 7, x squared, 25. But if I multiply this out, I get 2x to the 4th. No, 2x cubed. I get minus 50x plus 7x squared, and then minus 175. Now that almost looks right, but almost right is not the same as right. Okay, because if we rearrange that order, we get what? 2x cubed plus 7x squared minus 50x minus 175. See how it's not the same? Up here we had a minus 7x squared. Here we had a plus 7x squared plus 50x versus a minus 50x. So if you get those signs wrong, you're wrong. If you were convinced, like here's the order you should go through. If you really think you're doing a problem right and it keeps telling you you're wrong, here's the steps you should take. 1, make sure you wrote the problem down correctly. 2, double check your signs. Like that's a very common thing I see is students will call me over and go, it's right. I think it's right, but their signs are off. So check that, right? That's probably going to catch a lot of the issues. If you think you're doing it right and you're not, that's usually one of those two things. Okay. So that basically puts us out of time. So we learned greatest common factor and factor by grouping. We'll get into trinomial stuff next time. We'll have the test a little bit past the middle of October. And next week we can pin it down. Depending on how far we get on Monday, we should be able to pin down a test date and sort of get ready. So if you're slightly behind, get yourself caught up. Many of you are right on track, which is great. The rest of you, if you're a little behind, start getting caught up now. You don't want to be trying to get caught up in those with just a few days left. Get yourself caught up now. And then, do that. So, enjoy your weekend. Be safe. Catch up on your math and try to relax a little bit. And we will see you next week. Anyone who wants to talk to me, come see me in Zoom. I'll stick around. All right. Thanks, everybody.